right, so here we go. 0 to the 0, indeterminate. So I got to figure out what this goes to. I'm really going to start looking at, again, limit as x goes to 0 from the right of y, but that is the 0 over 0. So now I'm going to look at the limit as x goes to 0 from the right of ln of y. And let's say I get a number. Then my real answer is going to be, if I e both sides, then I'd get limit as x goes to 0 from the right of y, being that e to the number part. That's kind of, again, the thought process here. Okay, and we did that already on the last problem, and it was e to the number. That number happened to be 1, and e to the 1 was e. All right, so step 1, ln of y equals x ln of x. I'm now going to be looking at the limit as x goes to 0 from the right of ln of y, which is the same as limit as x ln of x. And as you go to 0 from the right, you're getting 0 times negative infinity, which is indeterminate. So we're going to force a fraction. Here we go. Force fraction. We're going to get limit as x goes to 0 from the right of ln of x over 1 over x. I'm going to plug in, and I'm going to get negative infinity over infinity. Negative infinity over infinity, indeterminate. So now we can take derivatives of top and bottom. Get 1 over x all over negative 1 over x squared. Before you try to analyze that, I would rewrite the fraction. And I get negative x squared over x, which is negative x, which is 0. Now, remember, that 0 that I got, that's the number part. So that is for the ln of y version. So we're going to e it back out. E it back out. We just learned the limit as x goes to 0 from the right of ln of y equals 0. So then that means the limit as x goes to 0 from the right of y equals e to the 0, which equals 1. Okay. So in this case, a 0 to the 0 goes to 1. So as x gets really close to 0 from the right side there, so you got like 3 cubed is 27, 2 squared is 4, 1 to the 1 is 1, half to the half is something, fourth to the fourth is something. In the end, that 1/100th to the 100th, and the closer you get to 0, that goes right to 1. Okay. Visually, if you want to see that on a calculator, let's just try plugging in a couple numbers so you can see that that holds true. Okay, so let's try 1/2 to the 1/2, 0.707. I could do 1/3 to the 1/3, 0.69. Let's do 1/9 to the 1/9, 0.78. So it's kind of been hopping back and forth a little bit. Let's try 90 over 90, 0.95. Now we're cooking. Now it seems to be kind of going towards that 0. 1 over 900, 1 over 900, 0.999. I think you get it. Let's just make it a 99. 99. And it's getting closer and closer to 1, like we predicted. Okay. All right, so that was another practice of logging. Okay, so try this one out. Okay, so if you want, you can hit pause a little bit. Try this one out. I have all of the answer revealed below. You guys can go to the boards if you want. This is 1 plus sine 4x to the cotangent of x. And when you plug in 0, sine of 0 is 0. So 1 plus 0 is 1. And cotangent of 0, think of it as this. If you're going, how do I know that that's infinity? Well, think through this. Cotangent is cosine over sine. And as you plug in 0 from the right, you're getting a 1 over 0. And that's 1 over really, really small, which is a positive. So try this one out, and we'll take a look in a second. Okay, so I called the main thing y, and I need to ln it. So when I ln, that falls down. And you're going to want to make that a fraction. That would mean you'd have the ln on top, and you'd have 1 over cotangent on bottom, which is kind of nice that that actually becomes tangent. If you plug in 0 for that, you're going to get ln of 1, which is 0, and tangent of 0, which is 0, so it's indeterminate. So you're going to take derivatives of the top and the bottom. There's the top guy, stamp, 1 plus sine 4x. Address, 4 cosine 4x. Derivative of tangent is secant squared. And from there, plug in, see what you get, and you actually get 4 over 1. So you don't need to go any further because you got 4 over 1 when you have that. I probably would have showed the step where that 3-tiered fraction merges into 2 tiers. But anyways, that goes to 4 over 1. Now remember, that is for ln. So your answer is 4 for the ln version. So to get rid of the ln version, you e it, and you just learned it is e to the 4th. So hopefully that's okay on that problem. All right. So a question that you might get that's more than just saying, hey, let's do Hopital, let's do Hopital, let's do Hopital, is a question like this. Y equals ln of x over x. Find asymptotes. Now, asymptotes are whenever the bottom is 0, those are vertical, and horizontal is whenever you're going to the infinities. So the easiest one on this problem to stare at is this is bad. This is 0 when x equals 0. So in this graph, I know I have an asymptote right there at 0. Okay. If you're curious on if it blows up or blows down, let's take a look at that. So do you agree? It could go here, or it could go there. Well, to find that, you're asking this question. Limit as x goes to 0 from the right of ln of x over x. That's what that question's asking right there. Limit as x goes to 0 from the right of ln of x over x. Let's see, that's going to be negative infinity over 0. Negative infinity over 0. Now ask yourself for a second, is that indeterminate? Stare at it for a second, ask and see. Of the 6 that I gave you, that's not indeterminate, so you must know this answer already. What is a negative big number divided by something really, 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 really small on the positive? Negative over a really small keeps you negative. So now I know it is that way, and I don't have that. So there's no Hopital there. Negative infinity over 0, you know that continues to stay at negative infinity. Now, on the right side is horizontal asymptotes. And horizontal asymptotes are when the x goes to the infinity. So we're going to want to look at limit as x goes to positive infinity. I'm not going to do negative infinity because I told you, hey, let's just make it x greater than 0. The reason I did that is you can't have negatives in the ln, so I'm only looking at the right side. And we're going to try it for ln of x over x. Plug in infinities, you get infinity over infinity, indeterminate. So you can take a derivative of top and bottom, 1 over x over 1. And that gets you 1 over infinity, which is 0. So I now know that this levels out there. Okay. So I could rephrase things to saying, let's find asymptotes. And what is the limit at those? Asymptotes vertically is when the bottom is undefined. Asymptotes horizontally are either at positive infinity or negative infinity. Okay. Let me see something here. Here's going to be your homework, page 564, 43 through 53 odd, 57, and 77. Now, at the very beginning of all these video lectures, there was a part on highlighting the different options there. Okay? And it looked kind of chaotic with all of the coloring. But remember, the big thing that I want you to realize is I've told you on this page that you can take a look at that like 37 and 39, those are kind of more like the 1 and 2 combos. And notice 37 and 39 were yesterday's homework. Now stare at some of these where it's like 43 and 45. That's more of the log guys that you might not like. That's 43 and 45. That's buried in that homework for tonight. Okay. So hopefully those are some good examples and you can get your feet wet with it. I did a 20-minute video, a 20-minute video, a 10-minute video. That's 50 minutes. Plus you did some stuff on the board. So you should have some good time to look at the following stuff together. See you guys. See you on Monday. No, see you on Tuesday.